begin to gather.
Yep, ladies and gentlemen, and variations thereupon, if we could get your attention and have you come back to your seats, please, as we get ready for the final sprint of today's event. There we go. Grab your refreshments. We've got one more talk and it's all good. This is slightly beyond the job description, but there we go. Alrighty. So as we know, we've got a slight change to the schedule today, so we're bringing forward our final speaker. It is a weird situation to find yourself in, first to be the first speaker at the event, to then introduce the final speaker at the event, but it is what it is, and here we are. I think speaking on behalf of everyone, Next Level today has been really interesting and really exciting, and of course it's only possible thanks to King's Institute for Artificial Intelligence and Dr. Mike Cook putting it all together. And so what better way to wrap up today than to hear a few words from the man himself. Ladies and gentlemen, please give a warm welcome to Mike Cook.
Thank you so much, Tommy, and thanks everyone. Thanks for the suggestion to do that as well. It was a good idea, yeah. So yes, hello. My name is Mike. I work here at King's College London. I'm in the Human-Centered Computing group, where I do research and teaching in and around games. I specialize in building generative systems, so using algorithms to make things. I've been doing it for nigh on 15 years now, so long before that word took on different meanings. And I also like to build systems that are kind of creative on their own. So I've built AI systems that have tried to design games on their own, again, a long time before that had the meaning that it means now. And use that to kind of think about what game design actually is. And working in AI these days is a stressful thing. So I put that little joke at the end, but it's only kind of a joke. Lisa actually has me screaming at her on Slack, usually every week, to some new headline about AI. And these are some screenshots from some of the things that I've made during my research. But I also make things in my spare time. So I make games and weird digital art. I like writing about them and doing outreach. And I do like using my research in games, but often it's sort of simpler techniques. And people sometimes ask me, well, if you're making AI to kind of support games design, why don't you use it when you're designing games? And I never really have a great answer to that question. But we're gonna touch on that briefly today. And I also like thinking about creativity and how we are creative with each other. And so I often end up trying to pick up new creative outlets. So I started crochet last year. I'm learning a musical instrument this year. And that's really fun as well. It gets you thinking about why we create stuff in the first place. So today I want to talk to you a little bit about what it means for an AI to invent something. The first rehearsal of this talk was 45 minutes long. Then I cut a lot out. And then Raluca canceled, and I thought, well, but I did not put the slides back in, don't worry. So there'll be slightly less of some of these things, but I'm going to talk about generating game mechanics. And I'm going to talk about why that's difficult, but why we still might want to do it. But first I wondered if you can name either of the two people competing, I shouldn't have used the word people, either of the two competitors in this game. Gary Kasparov and Deep Blue, fantastic, yes. So Gary Kasparov has his head in his hands. I've actually used this image several times, and I've only realized that this is the start of the game. None of the pieces have moved. He's just very stressed. I always thought this was like mid-game, and that's why I used it as an illustration. He's stressed because in 1996, he played Deep Blue, which was an IBM machine, and he won 4 games to 2. But a year later, they came back, and he lost 3.5 games to 2.5. And there's a lot of writing that's been done about this matchup, but it's quite likely that he lost because of a bug. In Game 2, Deep Blue did something unusual. It made a move at random because of a bug that it hit in its code. And this move was so confusing, and because Kasparov was expecting intelligence from the machine, he was convinced that it was doing something far beyond its capabilities. He accused the team of using human editing, like live, to sort of upset the game. And it seems to have set him on tilt for kind of the rest of the series, which he ended up narrowly losing. And of course, humans were involved in Deep Blue. They were all over the Deep Blue process, but they weren't allowed to modify the system while it was playing. They could only modify it in between. But there was a lot of human knowledge in Deep Blue. So it's really interesting to think about like at what point we objected to the human involvement. Joel Benjamin, who's pictured here on the right, he was hired by the Deep Blue team after their loss to Gary in 1996. And he's an expert at chess openings, and he wrote a huge book of chess openings that Deep Blue used. So these systems were built on top of loads and loads of human knowledge. It helped them do what they needed to do. But we are funny about like how and when humans get involved in these things. And that human involvement has become even more complicated today with generative AI. So Meta's latest advertising campaign for some of its video editing tools, they got this director to make a little advert about how he edited the very first movies he made when he was a kid. He edited them using their software. And he was talking about like, oh, the thing I like about this tool is that little Anish, that's him when he was a kid, would still have had to write a story and plan the shots and get the cameras. And it's just this tool is like just making it a little bit better. And the problem with this sales pitch is that there's no actual reason for that. Like he says that I would still need to write the story, but why? Why wouldn't you just use ChatGPT to write the story? Like I still need to force my brother to act, but why? Why wouldn't you just use the AI to like invent everything in this scene? Like why do anything? It's really interesting to see the PR lines coming out of these companies changing as people's reactions to generative AI tools has shifted. And they've realized that people want to feel that they're still in this process somewhere, so we need to kind of pull back a little bit from what we were saying initially. And we end up in this really very odd situation where some companies are telling you that generative AI means everyone can be an artist and you no longer have to train for years to be an artist. But the other companies are saying, oh, by the way, we actually still need humans in the loop. Of course, we can't get rid of humans. Your jobs are very safe. And the marketing, if you actually put them next to each other, is really, really confusing. No one seems sure about what the role of any of this technology is. And as long as you're only paying attention to one advert at a time, you won't notice. So this leaves us in kind of an interesting spot if we are looking at creativity. So chess was really interesting. It was like a significant moment where AI kind of beat chess grandmasters. But when we think about kind of why it gets more complicated when we look at like AI getting involved in creative domains, I think it gets complicated for a few reasons. First of all, we're really obsessed with the idea that AGI is coming, and so the AI has to be seen to be doing a lot on its own, and if we start talking about all of the humans involved in the process, that undermines that argument. The second is that we really don't want to talk about the involvement of certain humans in the AI process, because that could land us in legal hot water if, say, the EU, for example, decides that that actually was illegal, and then we might have to justify why we did it for so long. And of course, people really want to be first. So beating Garry Kasparov was very significant, but it was also very obvious who the first people to do this was. But if you look at creative domains, it's a lot more confusing. So if you look for what was the first movie written by an AI, you'll find out that it happened in 2024, and it was going to premiere a couple of months ago in London, but it got cancelled due to protests. However, it also happened in 2023 with a completely different movie called The Diary of Sisyphus, and it happened in 2016 where there was another first movie, this time called Sunspring. And if you ask Google's AI in their AI kind of search results, you find a fourth thing which definitely happened in 2024 called The Frost. And you can kind of debate the semantics of like, oh, well, one of them was a feature film, and one of them was the visuals versus the text. But the point is, everyone is scrambling for these PR lines of like, which one of us did this first? Which one of us managed to get an AI to do this whole creative process? And it's very, very confusing. And it's really, really confusing because we don't really know where we want to draw the lines between humans and AI in this process. So today I want to talk to you about a little something I've been working on and how it's made me reflect on how AI is part of my process. And that's a system called Pixie. So some of you might be aware that I've been building a system called Puck for a few years. Puck is a system that generates games, and a Puck and Pixie have the same root word in language. They both refer to these kind of sprite-like creatures, and I like it because the relationship with these AI systems is not one of like commanding them to do things. It's that you kind of work with them, and if you're polite to the Pixie, it won't do naughty things to you, basically. So today I want to talk to you about where the system came about. And before I do, I just want to give you a brief kind of summary of the different approaches to procedural generation. So one approach is what we call generate and test. So that means you make some stuff, you double check that it's okay, and then you include it in your game. And this is not very commonly used in games, but it is commonly used in research because it means that we can do more dangerous things and then just check that it works before we show the player. So it means that you can, if you're not entirely sure how to do something properly, but you know when you've done something incorrectly, it allows you to filter out afterwards. The second approach is what we call constructive generation, and that's when we know that there's a set recipe for how to do something, but we don't necessarily know what it's going to produce. Kate talked about this in her talk, and the analogy I had was making paper snowflakes. So if you fold a piece of paper up and cut it a bunch, you know it's going to generate a snowflake when you open it. There is no way for that process to fail. You may not know exactly what the snowflake looks like, but it will produce something. And finally, a more recent advance is PCG via machine learning. So that's the idea that you have a bunch of things already made, and you show a model those things, and then you ask it to produce new things that are like those input things. So Pixie is designed to generate game mechanics. So this is ideas for things that you do in the game, like systems, things that you collect, maybe opponents, events, any code that makes some kind of change in the game world. And the problem with this is, and this is something I've been thinking about for over a decade now, we can't really do it using the constructive approach or the machine learning approach. At the very least, it's not very easy to do this. And the reason for this is that the game typically has to be played for us to understand what the game mechanic does. So we can't use the constructive approach because we don't know what it's going to do until we've actually played the game. And we can't really use it by examples because every game is so different to every other game that there's just no data that we can show it. So a long time ago, over a decade ago, I proposed this system called Mechanic Miner, where we did a generate and test process. And this part was pretty difficult, the generating the ideas and the testing them. And this part was very, very difficult, actually evaluating whether the thing that came out was very good. But I'm going to talk to you briefly about how we did it and how I've tried to improve on it with Pixie. So the way that we had this working was we had this game, and we had a problem in it that couldn't be solved. So if you see in the middle here, you've got Mario in front of a high wall, and then there's a flag at the end that Mario's trying to get to. And Mario can't jump over it. So we get our system, Mechanic Miner, to generate a bit of code, and we attach it to a button on the keyboard. And then we say, see if you can get to the flag. And if we can get to the flag, then that must mean that that code did something useful. So we don't know if it was fun or interesting, but we know it did something. So it's like enough to show us a thing that can be done in this game. And we then use something that programming languages can do called reflection. And reflection means that the program can look into itself. It can examine its own code and make modifications to it. So we said, OK, here's a game. You're allowed to change anything that you can see in this game and just see what you come up with, basically. So one mechanic that it came up with is when you press the special ability button, it multiplies the gravity by -1. So Mario floats up to the ceiling, and that lets Mario walk across, and then once it's past the wall, it can flip gravity again. Another solution that it came up with was, well, the player has an X and Y coordinate. We can modify it. So when you press the button, Mario appears to teleport to a new location. And this is actually a little bit confusing because players don't know that Mario has a coordinate. They don't think about that. But the AI saw it as a solution, so it was still really interesting. And I was very proud of this system. It found things that I didn't know were possible, which is always really exciting when you're working on an AI system. But the problem is that we kind of want to be able to apply this system to real games. So this is Disc Room. This is an indie game that came out in 2020. And the question is Mechanic Miner actually usable by game developers? And the answer is no, really. That's the problem. So Mechanic Miner just didn't work. And so Pixie was me beginning to think about what would it take to actually build a system that anyone could plug into a game. The reason it didn't work is that as soon as you get into a game that you didn't make, you have a load of new problems. So we've never seen the code base before. So even though we can use reflection, a real game has thousands of variables, maybe tens of thousands of variables. It could be changing anything. It could be deleting data off the game developer's hard drive for all we know. So we need a way to actually know what we want to do in the code. We need to know what the game developer actually wants to do. So we attached it to some button that you press to make Mario move, but that might not be what the game designer wants. So how can the game designer tell Pixie where code goes? We want to be able to test the game mechanic. That's really hard because I had hand-designed that one room that Mario could look at. And we also need to know what we're looking for. Mario's a platformer. What if you're using this on a dating game or a racing game or some other kind of game? How can we actually easily express what we want? And it kind of goes back to what Kate was talking about today of how do we let people talk to a computer and say what they want? And I had some other kind of requirements for me, is that I wanted this to feel usable in a real game environment. And that means that it shouldn't have any side effects. So if you're working with a big team, the team should not be aware that you're using Pixie. It should just not be a thing for them. Ideally, I'd like there to be ways to change it without writing code. So maybe game designers that don't program can still use it. And I wanted it to still be easy to customize as well. So people had loads of levers that they could pull to use their knowledge to change the way the game worked. So the example I'm going to use over the next few slides is disk room. Basically, you have to avoid these disks that are moving around for as long as possible, and the disks all have different properties. And I'm going to use Pixie to invent a new disk type for this game. Unfortunately, we have an open source version of disk room, which is one of the reasons why I wanted to use it. So disk room special disks are really interesting. Some of them track the player, some of them spawn other disks. They move at different speeds. They have loads of different behaviors. It's a really fun game. We want Pixie to invent a new disk. This is not the only thing Pixie can do, but this is how I'm going to walk you through it. So the first thing is you can go into your code base, and you can write these little annotations above any variables that you want Pixie to be able to touch. And anything that does not have an annotation, Pixie does not go anywhere near. So this is really nice because this allows you to decide exactly what it's allowed to do to invent a piece of code. And you can even give restrictions on it. So you can clamp the value so that it's never between 0 and 10, which is another way for you to inject knowledge into the game. Because you might know, well, there's no point speed being negative, so just don't even bother trying. And this is another way to give you control. Then you decide where you want this piece of code to go, and you tell Pixie something should happen here, and here's the information I'm going to give to you. So for example, if we wanted Pixie to generate some code that happened when the player died, we would go to the on-player death piece of our code, and we would just tell Pixie, this thing happens here, do something. And this is all you have to do. Pixie will find all of these places that you've called things, and it will generate code for each one, and you can reuse them if you give it the same name in multiple locations. Pixie also knows the types of things that you're giving it. So in this case, we're giving it the player, because maybe it wants to know about the player. Maybe it can already find it some other way, but I've decided to make it easier for Pixie. Then we need a scene that lets Pixie play the game. So in disk room, this is very easy. It's just the game itself. But if you were making a more complex game, you might have to make like a little scene. And this is where it starts to get tricky. So you also need a way for the game to play itself. Now, there are workarounds that I'm not going to go into in this talk because it's too long. But this is something that game developers don't often have to do, especially indie game developers. So for disk room, I made this very simple player where each disk essentially pushes the player, and the nearer it is to the player, the harder it pushes. So that red disk that's very near it is pushing really hard in the opposite direction, but those disks in the top left are much more weakly pushing towards the player. And this is enough for it to play pretty well. There are ways to avoid doing this with Pixie if it's something that the indie developer is like not familiar with, but that's kind of outside the scope of this talk. And then finally, you need to, at the end of a play session, you need to tell Pixie how good was this piece of code for doing whatever you wanted to do. So you end up giving it a score between 1 and 0. 1 is a perfect score, 0 is the perfectly opposite score. And you have to think about, like, what thing am I trying to encourage Pixie to measure here? Maybe I want to make the game easier to play, so I want to increase the player's score, or I want the player to survive for longer. That's actually one of the ones that we use in disk room. I'll show you some examples in a second. But there are many, many different things you can encourage Pixie to invent game mechanics for. And this is another skill which is quite common in AI research, but it's less common in game design. But I think it's something that could be taught quite easily to game designers, especially once we've got these examples of like very basic optimization problems. So going back to this slide, we now have a way of telling Pixie exactly which bits of code it's allowed to touch. We have a way of telling Pixie where to put the code, because we can decide, yeah, we want some code for when a disk bounces off the wall. We've given Pixie a little bit of game that it can run, so once it's decided what it wants to change, it can run our game to test it. And we told it at the end whether it did a good job or a bad job. And this is all we need. Pixie now uses something called computational evolution to slowly improve and search for interesting mechanics that do something in this game. So to give you some examples, what was really important for me with Pixie is that I used other people's games. So I used 2 open source games made by Mads Johansson, who's a colleague of mine, an indie dev and an AI researcher. And the first one is Breakout. So I really like Breakout. It's an old arcade game that I love very much. This is a very basic implementation, as you can see. So the auto player for this was also very easy. You just basically follow the ball. It's as easy as it can possibly be. The first thing I said was, okay, Pixie, can you introduce some code that fires every time the ball bounces and it makes the game easier? And this is what happens. So this is actually a power-up in Breakout, but the way that Pixie's invented it is kind of bizarre, but incredible. Basically, whenever the ball bounces off a brick, it starts moving in the opposite direction, and Pixie has generated some code that then flips the velocity again. So it basically bounces twice, which means it appears to pass through the brick. And this means that the player breaks more bricks, which means that it gets a higher score, and Pixie gets a signal of like, yes, this did what I asked for. Then I said, do the opposite. Now make the game harder for the player. This one's kind of a cheat, but I'm just going to let you see if you can figure out like what's going on here after a few seconds. So the ball gets 10% smaller every time it hits a brick, and eventually you can't see it anymore. But weirdly, that is not actually why it's harder, because the AI doesn't care. The AI can see the ball no matter how tiny it is. The reason why it ends up working for the score is like a bit more nuanced, but actually, I mean, I laughed out loud in the middle of the coffee shop once I saw this, because this actually would be really hard if you were playing Breakout and this happened. So I really love this as an example. Yeah, it gets 10% smaller every time the brick breaks. So then we have Discrim, which I've already talked to you about. So Discrim, I sort of elided some of the details in Pixie, but one of the things it can do is invent new game objects. So these red disks are not in Discrim by default, but these are the ones I wanted to attach code to. So I said to Pixie, okay, you can change two things. You can fire some code when the game starts, and you can fire some code every time a red disk bounces off the wall. You can kind of see that, this is the other important thing. So for Discrim, the auto player, I made two different versions. I also made a version that delays its input. So it decides what it wants to do, and then it waits 5 frames, and then it gives the input. And this allows us to simulate kind of a player that has lower reaction time. And you'll see what this allows us to do with the next example. So I said to Pixie, okay, I want you to make a level where the better player with no delayed reaction time does better than the player with worse reaction time. And this is what it ended up coming up with. So again, some code is firing every time the disks bounce off the wall. So what's happening is, this is actually similar to the Breakout. I didn't realize this until I made the talk. The red disks are getting 10% bigger every time they hit the wall. And this is very interesting because this is not in Discrim, but it feels like it could have been. I was really, really happy with this output. But we can get Pixie to do much more interesting things than this. So I added a bit more code to the Discrim side of Pixie, and it breaks up the room into a 5x5 grid, and it says, okay, every time the player enters one of these grids, just remember, and at the end, your score is the number of grid squares that it entered. So basically, you want to try and make the player move around as much as possible. And the solution it came up with is really cool. So purple disks are disks that it can spawn, but they don't have any code attached to them. Every time the red disk bounces on the wall, it creates 2 new purple disks. But the purple disks are not very dangerous. They actually move very slowly. So the player is very easily able to avoid them, but it's constantly shepherding them around the room. So it is maximizing the amount of space that the player is forced to walk over. You can see how good the player is at Discrim, right? And this has a very, very simple implementation, but you can see here how Pixie was managed to optimize its route. By the way, in vanilla Discrim, the record for the player is 90 seconds, the auto player, but that's without any of these wild additions. This is also a screenshot from a time where I put the wrong thing in, and instead of trying to last the longest time possible, I asked it for it to last the shortest time possible, and it was like, sure, I can do that, I can knock that one out in 5 minutes, no problem. So here's the final example I want to give you. When I was building Pixie, I was testing it on a match 3 implementation that actually I made, so very similar to Bejeweled. And in my implementation, the color of the gem was governed by a numeric variable between 0 and 7. So instead of colored shapes, the code saw it as just a number. What Pixie came up with was a really interesting mechanic where it turns match 3 into a maths game. So watch, as I swipe the 2 onto the 3, it does 3 minus 2, which turns it into a 1. That creates a row of 3 ones, and they disappear. This was really, really interesting to me because this is not obvious when you are working in Bejeweled that it has this internal representation. And actually, maybe another programmer wouldn't have represented it this way. But I had, and Pixie was able to take advantage of that to introduce this new mechanic. But there's a problem. It did this basically by chance because I was still building Pixie when it came up with this. So Pixie was able to understand that this scored highly on the metrics I'd given it, but it wasn't evolving anything or anything like that. This was just, it just randomly generated this once, and it recognized that the score was high, and I was the one that looked at it and said, this is really good. And this example has kind of haunted me for a couple of years, because who gets the credit for this? If I was to write a paper and say, Pixie invented this game, and like I submit it to the IGF and it wins loads of awards, that would feel dishonest. If I made a game out of this and was like, I came up with this, actually, that just seems outright, like, obviously false. I could not have come up with this. I did not think that this kind of thing at all. So is this a sign that, like, Pixie's good at what it does? Not really, but it is doing something interesting. Otherwise, this idea wouldn't have come about at all, right? And this has got me thinking a lot about, like, this idea of having an infinite number of monkeys and an infinite number of typewriters. And the real problem isn't procuring the monkeys or the typewriters, although it is very difficult. The real problem is that monkeys don't know what Hamlet is. And the more you can tell them about what Hamlet looks like, and the more that you can be there to guide them, and maybe even be an editor to them, the better the monkeys are going to perform at the writing task. And what I've realized over time is that the reason why we're so weird about creativity is that it doesn't behave like lots of the tasks we apply AI to. So some things we do alone. Gary here is the most alone person in any photograph ever. There is no one to help him, and so is Deep Blue. Chess is something that you play alone in silence. And it has a very clear win condition. We know when someone has won, and that's why AI were able to declare victory. But creativity doesn't work like that. We're not creative alone, and that's why discussions over who influences who and where data comes from and what creativity is for is so tangled. Because when we make something, we're making something for other people. Maybe we're making a game for a loved one. Maybe we're making a game because we hope to make money. But whatever the reason, like, it's usually a very complex web of relationships. And similarly, there's no real way to win. Like, we have ways of ranking games, but they're not very effective or useful, and most of the people I know don't care about them. I mean, it might be interesting to know which games made a lot of money, and it's certainly nice to have money to be able to survive, but the favorite game that you played when you were young probably had nothing to do with the awards it won or how much money it made. That might have been something you recognized later as being important, but it didn't have anything to do with why you liked it. I don't think that what we need next for creativity is like more black boxes that just do stuff for us. I think that what's really interesting about Pixie is not even the use of it, but the building of it has taught me a lot about how to make games and how they work. And I think that AI is something that all of us build together, right? It's not even just software engineers, as Sinan was saying, like, it's all of us collectively. Deep Blue needed that opening book in order to beat Garry Kasparov. AlphaGo learned from many, many examples of professional Go play. Building AI has helped me become a better game designer. And I think that Pixie, or at least what I hope, is that Pixie might be a way to sort of encourage people to think about their own games in the same way, and to think about their games as little AI sandboxes that they can experiment in. And Pixie isn't going to make your game for you, but it might make you realize something weird about the way you implemented Match 3 that leads you to a really exciting discovery. And hopefully I can find out over the coming years. That's all I've got. I just wanted to say, I think I have a book coming out next year. I'm currently writing a book, and someone has asked me to give it to them next year. I don't actually know when it comes out or anything like that. But if you want to know, you can follow me on some social media sites. I actually did run a little overtime, which is absolutely appalling at the end of an event I organized. But if there is time for maybe one question, I could probably answer it now.
As a matter of interest, is there any way that you could see Pixie being applied to logic games like Go, chess, other board games similarly, where you have complete information in front of you and it's based solely on logic and strategy and tactics, etc.?
Yes, I think absolutely. Actually, when I originally built Pixie, the thing I thought I was going to test it on was roguelikes, which are much closer to Go and chess, so turn-based games with mostly perfect information. I actually have so Yunus, this is some of my students and colleagues on this slide. Yunus is actually really interested in analyzing chess, and they have some really great papers about doing word embedding work on chess, inventing new pieces. They have this amazing game where you can ask for a piece. You can say, I want a chess piece that's an angel, and they are really interested in like, how do you design that piece instantly? So I can send you some links to that kind of stuff. If you drop me an email, I'd love to pass those on to you. Thanks so much. I know that technically, like, we could take like another half an hour, but what I'll do instead before is that, again, since I'm speaking last, I wanted to add this slide on, and thank all of you for coming here and making Next Level like work as an event. The AI Institute, so if you ever came to one of the proc jams in times past that I organized or something like that, there was no like nice catering and cool like AV setup or anything like that. The KCL AI Institute helped support this event, and in particular, Catherine and Carly and Jess were all massively instrumental in doing basically everything that you have encountered today, making sure everything was booked and confirmed. And I also wanted to thank Kenji and Lizzie for putting up with my rather chaotic approach to PR and event management too. I wanted to thank the AV team for just bearing with us through all the tech issues today, and we're really excited to have the recordings to put up later. And one last thing is that we have a research showcase every year, and the next research showcase is happening on June the 10th next year, and you can come and meet not only people like me, but people from across the department who are doing amazing stuff in a variety of topics, many of which interface with games in interesting ways, which is why people like Sinem ended up coming and talking today as well. And if you would like to continue an extended coffee break session Q&A, we will be heading to the temple, oh my God, the temple. We'll be heading to this location. Let's just remove the transition there, and then it will just appear. So basically, if you exit this building through the security area and turn right, it's just a couple of roads down on the right. It is a pub, but it's a very cozy one, and I'm hoping it won't be too full at this time of day. If you'd like to join us for some chit-chat, please do come along. The next one, we will also have like a non-alcoholic mixer as well somewhere else, but some things I unfortunately couldn't organize this time. But I really wanted to thank you. When we came to King's, we wanted to do more game stuff. The AI Institute wants to do more support and AI stuff throughout King's. And having people actually come is the important part, right? Like, we can say we want to do all this stuff, but we want to create a community here. And so you've all been part of that community today, and I'm very, very grateful. So thank you so much. Thanks.